Welcome. So today we will discuss the another questions regarding recurrence relation. For the recurrence relation, we need to discuss about the homogeneous recurrence relation and non-homogeneous recurrence relation. We will discuss all the things for solving the given questions that is asked in the CSIT discrete structure. So welcome to my YouTube channel. I am Deepak Bhatta, an assistant professor from the Department of CSIT at Kailali Multiple Campus, Dhangadi, Kailali. Here you will find a variety of content related to computer science, information technology and many more. So don't forget to like, subscribe and hit the bell icon to stay updated with my latest video. So let's dive into the homogeneous recurrence relation. So a homogeneous recurrence relation is one in which each term is defined as a linear combination of previous term with no additional non-zero function or a sequence added. So means in general form we can say that if an equals to c1 an minus 1 plus c2 an minus 2 plus and so on so forth ck an minus k. So we have the combination of previous term, but we do not have additional functions. Okay, so here c1 c2 and ck are the constants. So let us take the homogeneous example, that is an. Here you can see an equals to 2an minus 1 minus an minus 2. So here you cannot see the additional functions. So the only part is the combination of previous term. So here you can see the another example, that is an equals to 3an minus 1 plus 4an minus 2 minus 2an minus 3. So there is no any other additional function. So in the question you need to find out the given equation is in the homogeneous recurrence relation or non-homogeneous recurrence relation. So let us see, the question is an equals to 3an minus 1 plus 2n. So can think that, or we can say that this is not a homogeneous recurrence relation because this is the additional functions, that is fn. So move on to the next part, that is non-homogeneous recurrence relation. So here I am just discussing about the homogeneous and non-homogeneous recurrence relation for the sake of easy way to understand the given question. So you need to clear about which equations is homogeneous and which equation is non-homogeneous recurrence relation. So first thing first, you need to separate either the equation is homogeneous part or non-homogeneous recurrence relation part. So move on to the non-homogeneous recurrence relation. A non-homogeneous recurrence relation is one in which each term is defined as a linear combination of previous term plus an additional function, often called the non-homogeneous part. So we have an additional part in the given question, that is non-homogeneous part, that is the additional function. So here you can see the general form of the non-homogeneous recurrence relation. An equals to c1 an minus 1 plus c2 an minus 2 plus and so forth ck an minus k plus fn. So this fn is the additional functions or often called the non-homogeneous part. So here c1 c2 and ck are the constants and fn is the functions of n not 0. So let us take the example of non-homogeneous recurrence relation. An equals to 2an minus 1 plus 3n. So here you can see this 3 raised power n is the f of n. So this is the non-homogeneous part. So also another example, an equals to 3an minus 1 minus 4an minus 2 plus n square. So n square is also a non-homogeneous part, that is additional functions fn. So I will mention some example of homogeneous as well as non-homogeneous. So if I take the example that is an equals to 5an minus 1 minus 3an minus 2 plus 7. So as you can see, this is the combination of previous term, so in the series. So this plus 7 is the additional function, often called the non-homogeneous part. So this is the example of non-homogeneous example, right? So let us take the another example. If I take an equals to 4an minus 1 minus an minus 2. So this is the example of homogeneous. This is the example of homogeneous, right? So let us take the another example. So third one. So if I take the example that is an equals to 6 an minus 1 minus 5 an minus 2 plus 4n. So this is the linear combination of previous term, and this is the additional function. So this is the example of non-homogeneous example. So likewise you can find which one is homogeneous and which one is non-homogeneous. So as per the given question, non-homogeneous example. So this is non-homogeneous recurrence relation, right? So now for solving any non-homogeneous recurrence relation, we need the following formula. Please note it down. So I have mentioned all the formula for solving the non-homogeneous recurrence relation. So first thing first, we need to find out this formula an equals to a raise h n plus a raise p n. So this is the formula for non-homogeneous recurrence relation. So where a raise p n equals to particular solution of non-homogeneous recurrence relation. So a raise h n is the solution of associated non-homogeneous recurrence relation. So also find the a raise n equals to alpha r raise n. So this is the formula for finding the solution of associated non-homogeneous recurrence relation. So also you need to find, if there is n, then you need to write a raise p n formula, that is c n plus d. So for the given question we use three formulas. So first one is this formula. So this formula you need to understand, or you need to remember this formula. This is second formula and this is third formula. So there are generally three formula you need to remember for solving the given question or any homogeneous recurrence relation. So now solve the question. So from the formula or from the non-homogeneous recurrence relation with constant coefficient, so we have the formula that is an equals to a raise h n plus a raise p n. So this is the formula. So now we need to find the a raise h n equals to 3a n minus 1. So in the given question, the asks a n equals to 3a n minus 1. So 3a n minus 1 is the a raise h n. So a raise h n is the solution of associated homogeneous recurrence relation, and this 2n is the additional function. So additional function sometimes called as the particular solution for the non-homogeneous recurrence relation, that is a raise p n, right? So we have another thing, that is a raise p n equals to function n equals to 2n. So this is the additional function, or we can write this, right? So now from a raise h n equals to 3 a n minus 1. So put the 0 in right hand side. So now write a h n minus 3 a n minus 1 equals to 0, right? So we need to calculate the degree. So since degree is, so degree you need to find here. If here it is 2, then degree is 2. So here we have 1, so degree is also 1. So this is 1, so degree is also 1, right? So now r raised to power 1 minus 3 equals to 0. So r equals to 3. So r value is 3. So r value is 3. So since we have only one root, since we have only one root, that is r equals to 3. So we have the formula. We use the formula as already told you, this formula, this one, a raise n equals to alpha dot r to power n. So this is the formula we will use here. So a raise h n equals to alpha into r to the power n. So this is n, right? So that is alpha into 3 raise n. So put the value of r. So here we have the value r equals to 3. So we have put this here. So a raise h n. So we got the value this, right? So now next part, that is additional part, that is this part. So now we need to solve this part. A raise p n, that is f of n equals to 2. For this we need to use the formula, that is now a raise p n equals to Cn plus d, right? As I have shown the formula here, so we are using n, that is if f of n, then we need to use Cn plus d. So Cn plus d, so this is the formula. So this is the formula. So given an equals to 3an minus 1 plus 2n. So we are writing from the given question. So here we are writing here. So now so we have Cn plus d, a of n is Cn d, equals to 3. So you need to put an Cn plus d. So here n minus 1, so C whole n minus 1 plus d. So you need to write here C n minus 1 plus d. Now you need to write this plus 2n as it is, right? So plus 2n. So we are putting a raised p n equals to Cn plus d. So an here Cn plus d from the formula, and 3an minus 1. So put this 3 as it is. So for an minus 1 we need to write Cn minus 1 plus d. So here n minus 1. So as we have shown here n minus 1, so we write n minus 1. So Cn plus d, n means n minus 1, so here we use n minus 1, right? So now substitute this form. So Cn plus d equals to 3Cn multiply minus 3C plus 3d. So multiply with 3 with this term, and 3 with this term, and 3 with this term. So we are multiplying the inner part. So write this as it is. So we are writing plus 2n as it is. So write this 2n as it is. We write 2n as it is, right? So now so 3Cn minus 3C plus 3d plus 2n minus Cn minus d equals to 0. So we make this equation. So now subtract the term, means make the same term. So plus 3d minus 3 minus d, and with 3Cn with minus Cn. So we got here, after making the same term, so that is 2Cn minus 3C plus 2d plus 2n minus equals to 0. So we are subtracting 3Cn with minus Cn, so plus minus minus, so 3Cn minus Cn, that is 2Cn. So we got this 2Cn. So we got this 2cn, and plus 3d minus 3d, we got the 2d plus minus minus. So we got this 2d. So remaining as it is, minus 3c plus 2n equals to 0. So we are reducing the term, having same term, we are subtracting or adding. Note it down in your copy. So for the easiness, so write it down in your paper. So now take the common. Take the common that is n. We are taking common n. Now 2c plus 2 n, we are taking common n. Then plus 2d minus 3c, 2d minus 3c. So 3cn plus 2n, we take the n common and write n 2c plus 2 plus 2d minus 3c as it is equals to 0. So now okay, I will make it clear. So for this part we can have two case. So case first, that is n equals to 0. So this does not provide any information about c, so we'll neglect it. So this does not provide any information about c, so neglect it. We will neglect this case 1. And case 2, we have 2c plus 2 equals to 0. So we will use the case 2. That is 2c plus 2 equals to 0. Now for this part, from this part 2d minus 3c equals to 0. So 2d minus 3c equals to 0. So we will use this as well. So make it equation 1 and make this equation 2, right? So now from equation 1 we have 2c plus 2 equals to 0, right? So 2c equals to minus 2, then c equals to minus 2 divided by 2, we will get c equals to minus 1. So we got the value of c, that is minus 1. So from the equation 2, so I will write here, from equation 2 from equation 2 we have 2d minus 3c equals to 0, right? So put the value of c, put the value of C in equation 2. So that is 2D minus 3 into minus 1 equals to 0. So 2D minus minus plus, so plus 3, 3 1s are 3, so sign is plus, so 3 equals to 0. So 2D equals to minus 3, so D equals to minus 3 by 2. So we got the value that is D equals to minus 3 divided by 2. Right, now substitute in A raised P n. So now, so this is the long question, so be patient. So write it down in your copy from the video. So now substitute in A raised P n equals to C n plus D. So this is our formula. So here C equals to minus 1, so this is minus 1, then D equals to minus 3 by 2, so this is D part. So now, so minus 1 n, so here C is minus 1 and n as it is n, plus minus 3 divided by 2, so this is the D part. So I will write clearly. So this minus 1 is C and this one is D, right? C n plus D. So now calculate the part that is minus 1n minus 3 by 2. So this is the value for, therefore A raised P n equals to minus 1n minus 3 divided by 2 divided by 2. So this is the value for A raised Pn. So now from An equals to A raised Hn plus A raised Pn. Now put the value. We have A raised Hn, we have just written over here A raised H, this. So A raised Hn equals to alpha 3 to the power n. So you need to write this value along with this current value, that is A raised Pn. So we are getting two value, that is here A raised H n equals to, we have alpha dot 3n and A raised P n equals to minus 1 minus 3 divided by 2. So An equals to alpha 3n minus 1n minus 3 divided by 2. So this is the value for An. So given question, So from the given question, we have, so let us see the question. So we have the a1 equals to 3. So a1 equals to 3. So we have a1 equals to 3. So an equals to alpha 3 raise n minus 3 divided by 2. So we write the same thing, 1n equals to, so therefore 1n equals to n. So minus 1n equals to minus 1n. So this is the same thing. So I remove 1. So this is the same thing. So remove 1. So now a1. So here a1 equals to alpha 3 1 minus 1 minus 3 divided by 2. So put the value of n equals to 1. So here n equals to 1. So now an, so value of an equals to 3, a1 equals to 3. So write it here. So 3 equals to alpha 3 raised power 1, that is 3 minus 1 minus 3 divided by 2, right? So you can put here dot, this is the multiplication, alpha 3. So now we can make it in simple way, that is 3 plus 1. So make this left hand side part, put it in left hand side part, so minus sign. So 3 plus 1 plus 3 divided by 2 then equals to 3 alpha, right? So this is the thing. So now from here make a common, that is 2, LCM, take LCM 2. So 3 into 2 plus 1 into 2 plus 3 equals to 3 alpha, right? So 3 dot alpha. So now 3 to the 6 plus 1 to the 2 plus 3 divided by 2 equals to 3 alpha. So what we will get is, so add all 6 to 8, 8 3 11. So 11 divided by 2 equals to 3 alpha. Now put this 3 cross multiply, that is 11 divided by 2 into 3 equals to alpha, or 11 divided by 6 equals to alpha. So now so alpha value is 11 divided by 6. So now an equals to alpha 3 raise n minus 1n minus 3 divided by 2, right? This is our expression. We need to put the alpha value over here, 11 divided by 6. So an equals to alpha value, that is 11 divided by 6 into 3 power n minus 1n, you can write 1 as well. So 1 divided by 3 divided by 2. So this is the final answer for the given question. So this is the final answer. So this is the final answer. So it will take a long time to solve this numerical. So hope you understand. So here we are putting the value of alpha, right? So don't get confused. So put the value of alpha, right? So putting the value of alpha. So we are putting the value of alpha, right? So this much for today. So hope you like it. So please make a note and write it down. So from the beginning I will show you all the things. First of all, we need to understand what is homogeneous recurrence relation, non-homogeneous recurrence relation. So in the given question there might be our homogeneous recurrence relation, non-homogeneous recurrence relation. So we need to find out which recurrence relation is in the question. So as per the given question, we have a non-homogeneous recurrence relation where we have the additional functions, that is the non-homogeneous part. So for non-homogeneous part we have write the formula, that is an equals to a raise h n plus a raise p n. This is the first formula, and we need to calculate a raise h n equals to alpha dot r n. So for a raise p n we have cn plus d. So here in the given question we have 2n, so 2n, so we are writing for n part. So in the given question they ask n square, so put it this formula. So if the given question is in constant, so the write the constant as well, that is c. So here in the question we have asked n, 2n, then we can write cn plus d. So from the homogeneous recurrence relation with constant coefficient, we have the formula an equals to a raise h plus a raise pn. So we have substitute the value, that is a raise h n equals to 3an minus 1. So from the given question, so this is a raise h n, so this is the first part, and in the second part there is plus 2n. So this plus 2n is the additional function, or you can write f of n, or a raise p n equals to 2n. From a raise h n equals to 3an minus 1, so we need to make the equation. So a raise h n minus 3a n minus 1 equals to 0. So since degree is 1, so r raise 1 minus 3 equals to 0, so r value is 3. So here we have only one root value, so that is 3. So we use this formula, a raise h n equals to alpha into r to the power n. So we get this value. Now a raise p n equals to c n plus d. So from the given question, a n equals to 3an minus 1 plus 2n. So we have substitute here cn plus d. So for an, cn plus d. Then 3an minus 1. So here 3 as it is, right? So an minus 1, that is c n minus 1 plus d, so plus 2n as it is. So cn plus d equals to c 3 cn minus 3c plus 3d. We are multiplying with inner part plus 2n. So we take the same term and subtract it and find the final equation and take the common, that is n. So we have three case, that is case 1, case 2, case 3. That is n equals to 0, it does not provide any information, so we neglect it. So we have just two part, 2c plus 2 equals to 0 and 2d minus 3c equals to 0. So this n does not have any constant value, so we remove it. So only constant value we will take and further for the further calculation. So from the equation 1, 2c plus 2, we will substitute c equals to minus 1 and put this value in the equation 2 from in 2d minus 3c equals to 0. So we will get c value minus 1 and d value minus 3 divided by 2. After getting c and d value, substitute it in a raise p n, that is c n plus d. So here we substitute the value, so we will get the a p n. So after getting a p n, we can use this a n equals to a raise h plus a p n. This is the formula for non-homogeneous recurrence relation. So put the both a raise h n plus a raise p n value over here. So we get the value of a n. So from the given question, they ask a1 equals to 3. So we need to put that n equals to 1 and a1 equals to 3. So after calculating, we get the alpha value. So again put the value of alpha in the an equals to alpha into 3n minus 1 minus 3 divided by 2. So we get the final answer. So hope you like this video. So please like, share, subscribe with your friends. If you enjoyed this video and want to see more on variety of topics, please hit the subscribe button